Boom! Yes, folks, Hume again. How are you doing? So this is the third video in our series on factorization. The first video we covered univariate binomials. The second video we covered bivariate binomials. And if you had followed those two videos, and more importantly, if you had done my exercises that goes with the videos or exercises from some other source, in other words, if you had taken the time to practice, then you would have developed some kind of rhythm that we could now take into this next phase where we're going to deal with factorization by grouping, or as some people like to call it, factorization by groups. The idea is the same. The basic idea of factorization by grouping is that you have a long expression. The expression is long enough that you could actually break it up into groups, literally. And as you break it up into groups, you will start to see some patterns emerging. You will start to see common factors, which would then take you into a different level of the factorization that will then give you the final answer at the end. So without any further ado, let me start the thing. Alright, so we have our examples as always. First example, if you had to factorize 2p cubed plus 10p squared plus 7p plus 35. If you had to factorize that, one look at this, you're looking for a common factor along the lines of what we have done so far. Right? Remember, when you're factorizing, the basic idea is to look for common factors. So your first instinct, you look across the entire expression to see if there's any common factor. You see, well, alright, you have a p cubed here, you have p squared here, you have p here. But we don't have no p here. So you're sure that there's no possibility of taking the p out. What some people do, and let me point this out as a mistake, some people will take this and they will say, alright, this in black is equal to p into 2p squared plus 10p plus 7 plus 35. Now this is technically correct. From a pure mathematical standpoint, there is nothing wrong with moving from here to here. The problem though is that 9 times out of 10, based on how the maths is structured, unless you're in a very special circumstance, and these special circumstances always come up from time to time, unless in a very special circumstance, there is not much you could do with this. There's not much you could do with this in terms of working out something else or following along with some other question or something like that. Alright? So what I want to introduce is following along the same lines, but slightly differently. So the same way that you could take this as a group and factorize, because you see the p running across 3 terms, you could take the same idea and apply it in a slightly different context. Right? So watch how we're going to do this now. So instead of taking the 2p cubed plus 10p squared plus 7p, what you can do, you could take 2p cubed plus 10p squared as one expression, and you could take the 7p plus 35 as another expression. This 7p carries the plus sign in front of it. That is important because we will get to the examples a little later on where this term here would have a negative sign in front of it, and we need to be absolutely certain of what we're doing in that particular instance. Right? So you have two groups. So let me say we put a square around this one. That's group 1. And let me say we change the shape and the color. And let me say in green now. Green, boy. Green, let me go blue. Yeah, blue. I'm kind of concerned about the brightness of the green marker. Let me say in blue now, as a nice oval, you have 7p plus 35. Two separate expressions that are joined together by the process of addition. So basically, what this expression is, in mathematical fact, is 2p cubed plus 10p squared plus 7p plus 35, right? So I separate them physically by space, but you wouldn't get that on an exam, you wouldn't get that on a question, you wouldn't see that in the course of doing maths. So in other words, you have to be able to get a sense of when you need to factorize by groups. And of course, one of the ways in which to get that is by practicing. So usually when you see a long expression like that, 9 times out of 10, you have to invoke factorization by grouping. Alright? So if you had to factorize this separately by itself, right, following the procedures and the processes that we went through in factorization 1 and factorization 2, this here is a univariate binomial. Well, let's see it. See how it come back again? Right? Just one variable. You can have questions like these where you have 2 variables too. Eh? But for now, this is one variable. So you factorize. You factorize and I get what? P squared is a factor, 2 is a factor. I just going right at it, right? I'm not going through the whole long working as we did in the last 2 videos. So if you factorize this, you'll get 2p squared into p plus 5, right? Still plus, and then over here, 7p plus 35. Same univariate binomial, right? You have 7 as a common factor, so you have 7 into p plus 5. So you invoke the other thing that I would have mentioned in my first video on factorization that I tell my students about all the time. Observation, right? So you look, you see p plus 5 here and you see p plus 5 here. So across this entire expression, you realize that the whole of p plus 5 is a common factor. Let me illustrate. If I had told you to factorize 2p squared, right, by k plus 7p k, right? If I give you this expression, no, plus 7k, sorry, my mistake. If I give you this expression and I told you factorize that, you look at this expression immediately and you see that k is a common factor, right? So when you factorize that, you take the k out, right? Look the k here, brim, and look the k here, bram. You take the k out, and what you end up with would be k into 2p squared plus 5. No problem. Plus 7, sorry. Right? Let me write it down here just to make the point. K into 2p squared plus 7. Right? Nice. So everybody could see the movement from this to this. We mightn't be able to see it as clearly here, except that, watch it here, 2p squared by p plus 5, same k there, plus 7 by p plus 5, same k there. So the same way we had k running through this expression as a common factor, one physical entity, the letter k, the variable k. The same way we have an entire expression now, p plus 5, running through this much longer expression as a common factor. So p plus 5, that expression p plus 5 is a common factor across everything here, which would then put us in a position, this is supposed to be a 7 here, and I'm going to put it here for the record. Right, which would then put us in a position where we could take p plus 5 out of this larger expression as the common factor, and what do we get? We will get, and I'm jumping down here in black now, p plus 5 on the outside into, look at here, 2p squared plus, and look at here, 7. Right? P plus 5 into 2p squared plus 7. The same way that you ended up with k into 2p squared plus 7 here. The same way that you end up with p plus 5 into 2p squared plus 7. Alright? So the procedure is identical whether you're factorizing 2p squared k plus 7k to get k into 2p squared plus 7, or whether you're factorizing 2p squared into p plus 5 plus 7 into p plus 5 to get p plus 5 as the common factor into 2p squared plus 7. That is the basic foundation for this thing that we refer to as factorization by groups. You divide a longer expression into two groups. You factorize each group separately, and then you do that as part of a longer expression, and you realize, but wait, we have p plus 5 here and we have p plus 5 here. In other words, you have a common thread, a common factor running through the entire expression. That now you could take out as part of a process of factorization and get the answer. The factorized version of the original expression. Alright? So we're going again. So yes, so in other words, you start here, you get here, and you get here. So what I will do is do over the same question, but I will run it through the way you will run it through in an exam. So in other words, this is me breaking it down using an appropriate example so you can see the parallels and get a clearer sense of understanding exactly what it is you're doing. Now I'm going to just use the same question and run through it so you could get a sense of, alright, how we could run through this. Right? So in other words, by the time you get to the point of running through, the understanding must be there. Which is why sometimes when I teach in these things, it takes so long and it takes so much time, because I really do try my best to break it down and break it down and break it down. And after we go through that, then we could get to the point of just running through stuff. What a lot of people do, they try to jump the breaking down phase and skip to the running through phase. They want to go there fast, they want to run through. And when you're trying to run through without the understanding, at some point, sooner or later, you're going to run into problems. And that is what happens with most people. And then they tell themselves maths don't like them. It's not that maths don't like them. It's you not having treated the maths with the respect that it needs to be treated with. Even the easy topics, there is a process that you have to go through. Try to the best of your ability to understand the thing. It will take longer for some folks than others, that's fine. Right? But once you stick with it and you fight with it, then yeah, you have a clearer sense of understanding of what it is you're doing. Right? So there we go. Same question we're doing over. This time we're just running through so that you get to see what it would look like, let me say, if we had to do this in an exam. Right? So you spend the time before the exam developing the understanding, developing the awareness, developing the confidence, and the competence. You see how nice the words sounding together, rhyming and thing, right? So that when you go on the exam, you could just execute and have no doubt at all that what you wrote is actually the correct answer. All right, so let me go again. 2p cubed plus 10p squared. Hey, dry up now, what happened? Man, come to right here, man. 2p cubed plus 10p squared. 2p cubed plus 10p squared plus 7p plus 35. Right, long expression, 4 terms. So if you have binomial and trinomial, as we discussed before, a binomial is 2 terms, trinomial is 3 terms, 4 terms is what? Whew, pressure boy. Let me see if I could pick up some vocabulary here. Hold on, eh? Yeah, don't mind. I know you're telling yourself, well, why you just continue? We want to develop a certain level of interest and awareness in the thing. Binomial, trinomial, hold on. Give me 2 minutes here. Binomial, trinomial, you get the point. Let me see. Monomial is 1 term. Monomial is 1 term, right? Mono is 1. Trinomial, let me see what 4 terms is now. A quaternomial, maybe. Quadrinomial, ay. You see, I learned a piece of vocabulary there. Yeah, pressure boy. So, binomial is 2. No, monomial is 1. 1 term. So a monomial would be 1 term. 2p cubed by itself is a monomial. Just bear with me a little bit, okay? I want to let it really go deep in the maths. So 2p cubed is a monomial. 2p cubed plus 10p squared is a binomial. 2p cubed plus 10p squared plus 7p is a trinomial. And 2p cubed plus 10p squared plus 7p plus 35 is a quadrinomial. Maybe 5 terms is a pentanomial, I don't know. We go find out one of these days, right? And that is a learning experience for me too. In all my years of doing maths, I never knew what the exact word for a term with, for an expression with 4 terms was. I didn't really need to know it. But as I hear and I find myself in a situation, I say, all right, monomial, binomial, trinomial. I wonder what 4 terms is. Something with 4. Boom, quadrinomial. And that, folks, is the attitude that I want to encourage. That attitude of curiosity, that attitude of wanting to find out more. Wanting to learn more about whatever it is you're doing. Whatever it is you're doing here, there is always something that you could learn. There's always some improvement that you could make. There's always some way that you could investigate how to do the thing better. Don't get too complacent. As I tell my students all the time, if you get 95 in an exam, your first instinct, apart from feeling good about the 95, so your first thing is to feel good about the 95. The second thing is to try and find out where you lose them 5 marks. What happened to cause me to get 95 instead of 100? That is the attitude and the mentality that you have to have even when you're performing at the highest levels. You want to find out what happened there, how I lose them marks. Yeah. Right, so we're going again. So 2p cubed plus 10p squared plus 7p plus 35. Right. So you observe first law of the jungle. You realize, well, this here is, I'm refactorizing now. This is what? 2p into p squared plus 5. P squared plus, no, 2p squared, sorry, my mistake. Into p plus 5. Now I hope that you could see that to do this in one line in the context of a factorization by groups question, your factorization has to be on point, which is exactly why in my own situation, between the univariate binomials and the bivariate binomials, we have 120 questions to practice. So that by the time you reach here, you're not wondering, ifing, and butting, and you're sure, right? You need to be clicking like that if you're here, right? Same story here. 7p plus 35. You have the 7 into p plus 5. And then you realize, well, all right, p plus 5 is a common factor. So you take the p plus 5 on the outside as the common factor into 2p squared plus 7. Now, there are folks who haven't gotten to this point. They know immediately that your next line, and some of them will write it like this. They will write it as 2p squared plus 7. They will go here first, and then they'll put into p plus 5. Right? I want to assure you all categorically that there is no difference between these two as far as getting your marks in the exam is concerned. However, from a teaching standpoint, if I have to explain what factorization by grouping is, what I would do, just as we did a little while ago with the k and the p plus 5, I would emphasize the fact that p plus 5 is the common factor, which means that you're taking p plus 5 outside. And then inside the brackets, you have 2p squared plus 7. We just explained that we're using k as an example. So that's the idea. But I want to reiterate that this in black here and this in red here are identical for mathematical purposes. So if you're one of those people who will go from this line to this line in red, no problem. But for the folks who still trying to understand it, it would probably be better if you move from here to here so that you understand what you're doing. You could feel it, it could flow, and then you could run through with it, even under the pressure of an exam. All right, so next one. Let me see. Right, rub off the board a little bit and thing. Right? Yeah, factorization, nice enough, but it's serious. Not because it's nice mean it's not serious. You understand? Something could be nice and serious too, you know. Yeah. Nice doesn't mean fun and games all the time. Yeah, serious business, serious business. Right, so 6x cubed. Papa, you must cover up here, boy. Let's just make sure the signal coming still. Yeah. Right, so we're going again. Next one. 6x cubed minus 24x squared plus 5x minus 20. Same kind of thing. Another quadrinomial or quadrinomial, however you choose to pronounce it. Same principle. You have one group here and you have another group here. So you say, well, all right, no problem. This here, and again, I'm just factorizing in one line, right? 6x squared into x minus 4 plus 5 into x minus 4. Again, you look at the entire expression, you see that x minus 4 is a common factor. So you take out the x minus 4. So your next line is x minus 4 into 6x squared plus 5. End of discussion. Problem done. Right? So factorization by grouping is one of those areas where if your basic factorization is sound, once you could spot the grouping here, bam, and usually you would finish within 2 or 3 lines. That is how it is. But again, this has to be in place. Must be in place before you could run through this easier. All right, so we could go straight on to the next one now, which is, all right, next one. And here's where we start our next level of the thing now. Because let me write the question on the board first. 25 the xw plus 20 xf. No, we need some space. Hold on. We're going again. 25xw plus 20xf minus 15yw minus 12yf. Woo, pressure boy. Yeah? So, as you could see, the first thing you notice, if you were noticing, is that in contrast to the first two examples, in this one, the third term carries a minus sign in front. So in other words, the first term of the second group, right? Remember, it's 4 terms we're dealing with, so each group would have 2 terms. The first term of the second group has a minus sign, which makes things a little more complicated. So what I want to do is go back to something that I would have been mentioning initially, and I want to show it even more clearly here so that you understand exactly what it is you're dealing with. What I want you to see is that this long expression here is actually 25xw plus 20xf, right? And I'm going to put the plus sign by itself here to emphasize the point that it is this here in blue plus this here in blue minus 15yw plus minus, what that would be? That would be, hold on, just now. Minus 15 plus, yeah, minus 12 yf, right? So this minus sign that you see in here is actually plus minus. So in other words, what you essentially have is 2 separate groups that are separated by a plus sign. So I want to underscore the points. The 2 groups are always separated by addition. However, you have to take note of the sign of the first term in the second group, right? That way, it allows you to see even clearer the fact that you're factorizing 2 separate groups. So that if you're factorizing, you have here, the common factor here will be 5x. This will be 5x into 5w plus 4f, right? And if you treat this as a plus sign, and you try to factorize this here now, you realize that you now have minus 3y into 5w plus 4f. You see? So if you treat this case where you have the negative sign in front of the third term as one group added to another group where the second group carries a negative sign in front of the third term, then it puts you in a position where you could factorize this by itself, boom, and you factorize this by itself, and look, you have the same situation where you have 2 common factors, right? So now you could say that this in blue here is actually 5x into 5w plus 4f minus 3y into the same 5w plus 4f. Yeah? And once you get here, you can move to the next step and take out the 5w plus 4f as the common factor and say that your final answer here will be 5w plus 4f in brackets into 5x minus 3y. Right? 5x here and the 3y over there. Now, of course, as we said on a number of occasions, there are people who will get from here in black to here in black. Sometimes they don't even have the full arithmetic, the full mathematical, the full numerical understanding of what they're doing. But they're so practiced that they know, as soon as they see this, they know that this is what happens. Right? In terms of, you kind of do it kind of fast, almost subconsciously. But again, for teaching purposes, my role is to open it out and to break it up as much as possible so that the folks who having some trouble with it, who don't really understand why we move from here to here, because there are people who will try to factorize this as 15yw minus 12yf, not understanding that this 15yw is not 15yw. It is minus 15yw. You must consider the sign at all times, whether the sign is implied as the positive sign is here, or whether the sign is stated as the negative sign is here. And I want all to see that this minus 15yw, once you make that decision to consider it, as you must, the next step is to understand that this entire expression is is actually all of this plus minus 15yw going down the road. This key here is what will open the door to move from here to here and to here, if you don't have this part in blue fully clear. Otherwise, folks will jump from here to here. Eventually, what we want is that even those of us who had a little difficulties with the minus sign, and yeah, sure, y is minus 15yw instead of plus 15yw. Once you see it this way, if you choose to take the route of working it out like this, then do that. Eventually the fluency will come, where you'll be able to move from here to here in one line. But more importantly, you will understand exactly what you're doing. And once you get here, the problem is practically over, because you have 5w plus 4f as the common factor into 5x minus 3y. End of discussion. Right? Nice. So yeah, it's serious. It's a proper workout. But that's how the maths is. And that is what most people try to avoid. At the level of the students, people want to get lazy. They want to do the work. They want to go to class. They want to do the homework. They want to watch the video online, blah, 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 blah. And they expect to do well when they go in the exam. And on the side of the teachers realize not everybody. The teachers realize that there are a lot of lazy people out here. So hear what they want, hear what they do. They say, well, I'm trying to make money, I'm trying to get students in my class. So they promise you an easy package. They make it look like it's easy. They might put a little crash course before the exam, or they will try to sell the thing as an easy thing. Just come and we're going to mash up the maths. It don't have that, you know. Just come and we're going to mash up the maths. No. The only way you'll mash up the maths is if you go through the process. You have to go through the process. And yes, some folks will catch it faster than others. But it doesn't mean that those folks who catch it fast didn't go through the process too. And it doesn't mean that those folks who catch it fast did not have their moments also, where some little thing bugged them. Right? Somebody have a issue with some topic. Right? No matter how good somebody is, there will always be a situation where one or two topics kind of, they might not like the topic. There might be something about the topic that's taking a little longer to catch. It have that for everybody. But once you maintain your correct work ethic, and you have a little patience, you'll get where you need to get. Right? Nice. So the last permutation, that's the word we're using right through. The last permutation for the factorization by groups is, right? And again, just as we had here, you will find that the third term out of 4, remember we're dealing with quadrinomials, right? The third term out of 4 carries a negative sign. That is what will complicate matters for most people, right? As I keep saying all the time, once we have an expression where all the terms carry positive signs, that's level 1. Everybody comfortable there. The minute you introduce a negative sign, things get a little more spunky. And you find that, yeah boy, pressure. So I tried my best to explain it, to break it down, to open it up. And then you could get some questions to practice. That is what you have to do. Right? So, last permutation here in the factorization by groups. We have 24mn minus 15mx squared minus 56mn plus 35x cubed. Right. So again, just as we discussed in the last example, what actually happens here in the case where the third term, right, the first term of the second group, because it's 2 groups, right? You have this group, the first 2 terms, and this group in the second 2 terms. What you actually and truly have here is 24mn minus 15mx squared, first group, plus, right, plus minus 56mn plus 35x cubed, which when you factorize, you will get 24mn, 15mn, that's what, 3m, 5, 8 and 7, 3, no, 3 here, 24, 15, 3, 5 and 8, 7, 5 and 8, okay. That's just me kind of running through it kind of quick. But if you're not at that level, what you could do, take your time, take your time. Don't try to look at the 2 of them at the same time as I did there just now. Everybody wouldn't be able to do that immediately. You'll probably get there too, you know. You run through it in your head and then you start to look across here to see if you could spot the common factor one time. But in the interim, before you do get there, make sure and factorize properly first. And then you factorize properly across here. One of the things you could do, maybe not for the final exam for CXC or whatever your regional or national exam board is, but maybe for your school, there are these pens now that you could erase, right? You could use those, and if you had to erase anything, you erase it and you write it over. I wouldn't recommend that though for your final board exam, because in those cases, the exam papers normally have a longer distance to travel before they get to the point where somebody correcting it. And the longer the distance, the more time it takes, the greater the risk of the ink, you know, getting lighter and disappearing and all of that. So if you're using the erasable pens, do that only in your school exams, where the teacher right there, if there's anything the teacher could just call you and find out, well, you know, what were you really trying to say here? That option will not be available in your board exams. Right, so that's some advice on this side. So back to the maths now. So you're remembering that when you have the minus sign here, it is actually plus minus. The plus sign separates the 2 groups. Even in the case where the first term in the second group carries a negative sign. The two groups are always separated by addition. It is just that you add in and the negative sign is in front of the first term there. Right? So in this case, what you will have? You will have 5m into, not 5m, 3m, sorry. 3m into 8n minus 5x squared. Right? And then your plus. Watch it now. Here's where the magic starts. Minus 7. Minus 7. Why are you right here, boy? No. This is supposed to be 56xn, you see? Jeez, I write the wrong thing, boy. Yeah, but I have it right on the paper here, don't worry. This is supposed to be minus 56xn. I'm sure somebody see that already. Somebody who watching the video. Right? Right. Minus 56xn. Right? This will be minus 7 into 8n minus 5. Minus 7x, sorry, my mistake. Minus 7x. See how carefully I had to be here? Minus 7x into 8n minus 5x squared. Right? See? 8n minus 5x squared here. 8n minus 5x squared here. The terms, the expression inside the brackets for the both groups under factorization must be the same. So if you're doing a factorization by groups and you realize that the expressions are different inside the brackets, the two sets of brackets, that is your opportunity to say, all right, something going on here. Let me double back and check and see if there's a mistake. You have to be aware, you have to be so aware that when certain things pop up, certain irregularities, that we call it that, right? You realize, nah, something wrong here. And you could go back and check it. Right? But the idea is you wouldn't have that problem. So let us proceed with this question. So again, you have the 8n. So your next line would simply be hold on, let me just write the thing how we would write it if we were doing it. So you would have now 3m. This would be, all right, let me just write it over. Let me just write it and finish it. So here now it would be 3m. No, let me write it over. So basically you have 3m here into 8n minus 5x squared minus 7x into the same 8n minus 5x squared. Right? This plus by this minus will give you a minus here. So your next line, of course, would be 8n minus 5x squared as a common factor into 3m minus 7x. All right? Of course, as we just discussed a moment ago, it's a 4, not a u, right? 24. And this is a 2, not a z. Right. So as we just discussed a moment ago, you could very well get from here to here in one line. But in the case where you're not quite there as yet, I took the extra step of breaking this up and opening it out so that you have a clear understanding of exactly what you're doing when you say that you're factorizing by groups, especially as we have here the particular case where this is x to xn, right? 56xn, where xn, where the first term in the second group is governed by a negative sign. All right? So that more or less takes care of factorization 3, factorization by grouping. The next step we will go to is quadratic factorization, which is a big issue for most. But what I wanted to understand is that without the preceding steps of factorization 1, which is univariate binomials, factorization 2, bivariate binomials, and we just did here factorization 3, factorization by grouping. Without those 3 in place, you would have a lot of problems doing the work that we're going to cover in factorization 4, which is the quadratic factorization, which, as you will see, is another form of factorization by grouping. And as we discussed here, in the factorization by grouping, all of the preceding factorization is pretty much taken for granted. All right? So as always, get your questions and practice. Maintain that work ethic. Stay in the game. That is how you win it. You have to stay in the game.